Yes. Today we will learn what are the operators are present in Python programming. So Python operators. So first we will learn what is an operator. Operator is nothing but it is a symbol. Okay. Example. Plus. It is one operator. Generally it is a symbol. What does this symbol do? It will perform mathematical operations. Okay, so let us know what are the different type of operators were present in Python. First one, arithmetic operators. Next one, relational operators. Third one, bitwise operators. Fourth one, assignment operators. Fifth one, membership operator. Sixth one, identity operator. Next, seventh one, we go for special operators. So under special operator, we will learn ternary operator. And the other name of this one is conditional operator also. Conditional operator. So we will go for these all operators in detail with example. So first one, among these operator, we are learning with the first operators, that is arithmetic operators. So what are the different arithmetic operators present in Python? We will learn. So first one, plus. This one is addition operator. Next one, second one, minus. This will do subtraction. And third one, asterisk notation, which will do multiplication. Next, we'll go for fourth one. This is division. We call it as a division operator. And fifth one, we have two forward slashes. We are calling this one as a floor division. Okay, I will tell you difference between these two with an example. These two can do division only, but the result will be changes when you use these two different operators. Next, sixth one, percentile. This is called modulus operator. What does it do? It will return the remainder of given numbers. Next, seventh one, two asterisk notations. This is the exponent operator, or we may call it as power operator. Okay, let us know how to write the syntax of these all operators. So here, to do any operator related to arithmetic, at least we need two values. Okay, so first one, I am taking x value and y value, and I am going to initialize some values to this one. So when you are required data present in x and y, how to write the addition syntax? Very simple thing. We have to write two operands. We call this x and y as operand, and these two are connected using plus. Next one, x minus y, x asterisk y. Next one, x division y. Next, x floor division y. Next, x modulus y. Next, x 2 stars y. So these are the syntaxes and which returns values. Let us know what is the value it will generate. So if I give x value as 10 and y value as 3. So x plus y means 10 plus 3, we will get 13. 10 minus 3, we get 7. 10 into 3, we get 30. Now we understand how this division will be work. So when you do this division operator, this will give the result in the float. Exact division it will do. So for example, 10 is the number. When I divide with 3, 3 3 is 9 and I got remainder as 1 and it never stop this one. We'll do another division by taking that and 0 will be added. 3 3 is 9. Again I get remainder. Like this it will continue. So what is the result we get when I do division? 3.3333, like that it will appear for certain digits. Next one. When I go for these two divisions operator, means we call this one as a float division. When you do float division, it is also gives the quotient only. But what happens? It will give the result in the integer format. So this is the actual result when you do division operator. But when you do float division, you won't get this exact result. So it will give the result in integer representation. So dot followed by remaining value will be deleted, ignored, and we will get only 3 as a output. Next one, x modulus y. What it does? It will do division operator only, but it will give a result in integer type only, and the result will be written as a remainder value. Okay, so this modulus operator is also to perform division only. But what it does, it will give the remainder value. Means when I divide this 10 with 3, so 3 3 is 9 and I got result as 1. This 1 will be written when I apply x division y operator. Next one, x power y means 10 2 stars 3, which means 10 to the power of 3 and I will get the result as 1000. So I will get result 1000. So this is the way we will get the result when I do arithmetic operators. So we have to execute these all using Python program. So I will go for Tony platform. Tony, and I will do all arithmetic operator on 10 comma 3 and we will check whether it is giving same result or not. So here I am taking x value as 10 and y value as 3. Next, I am going to get the result like this. How can I get? I want to get the result like x 10, the sum of 10 and 3 is 13. I want to get result like this. So here, when I go for this message, this is the simple text. When you want to print a simple text, we will use the print function. And which message you want to be print, that you need to write inside the double quote. So the sum of I have written. Next, what is this 10? This 10 is the x value. So I have to write x. I won't put any quotes to print this 10. And these are the two different items. So these two can be concatenated using the comma operator. Next, followed by I have message which is and I am writing inside the double quote. Again, these two separated using the comma. Next, I want to print 3. This 3 is present in y variable. So y I am writing. Again, these two are separating using comma. Next, I have is. Again, is I am writing inside the double quote. These two are separating using comma. And 13 is the result of this 10 and 3 when I do addition operator. So I am performing x plus y operation, and these two are two different items. Again, I am separating these two using the comma. Okay, so this is the line I am writing to get the result like this. So let us see whether it is working or not. So I am writing print the sum, comma, x, comma, and double quote, comma, y is, comma, x plus y. I am writing like this. And I am running this program. When I run, so I can see the result. The sum of 10 and 3 is 13. This is working fine. But if you observe this one, I am executing the same program one more time. Again, what happens? This program is working perfectly for x equal to 10 and 3. And I will get the result. But let us understand one scenario at here. So generally, who will write this program? Minute. Yes. So who will write this program? This program is written by the developer. Okay. So who can see the result? End users can see the result. Here, always end user getting the result of 10 plus 3 only. So he developed this application and stored on a device, it is the calculator device, and this device is purchased by this person, this calculator doing sum of 10 plus 3 only. So here, what this end user is expecting? End user never expecting the sum of 10 plus 3 always. So he want a device or calculator. This calculator wants to do addition of any two numbers which are given by the end user. But what is the problem this calculator application has? This can do addition of two number only. So we have to give values to this calculator dynamically. What are the values end user has given? That's the sum my calculator want to do. So here we have to give another dynamic nature to my calculator, that while printing the sum of these two numbers, initially my calculator should ask end user to give two integer numbers. What are the integer numbers that end user has given? On that, these two sum need to be performed. This is my requirement. So that instead of assigning this value directly to the variable, I need to ask user which two variables sum you need to perform. So that instead of assigning these values statically, we have to ask the end user to give x and y value. So how can I ask? So Python program has given one predefined function, which is int function, input function. What does this input function doing? This input function is to accept the data which is given by the end user. Okay. So I am going to write this one, and we will check whether it is working or not. So here, this input function syntax I am writing. How can I write input function? First, we need to write input. And what is the you are expecting from the end user, that related message we need to write inside this double quote. So if I want to assign this value to X, what happens? I need to take input function and I need to ask which type of value you are expecting to the integer. So what I am doing, enter an integer like that. I will write one message. Then when I am executing, what is the message I have written at here? That will be displayed to the end user. Then end user ready to do the value. That value will be taken by input and that value will be copied to X variable. So let us see how it behaves. I am taking input value and I am asking user to give two integer number. Enter first integer I am asking. So user will give the data. Next input, enter second integer I am asking. Then user give the data, that value will be copied to X variable. So let us check whether it is working. When I run this one, now it is asking me to give a value. So what I am doing, I am giving 10. Next, it is asking me to give another integer value, which is second one. Again, I am giving 3. Next, when I hit enter, what is the value we are expecting? So definitely we are expecting 13 value. Now we will check whether it is printing 13 or not. No. Instead of 13, it has printed 103. Why it is printing 103? Because this input function is having one default behavior. What is that? When you write input function, okay, it doesn't matter what is the value you have given. Means which type of value you have given, that doesn't matter. Always this input function read the given data as a string format. How it read? It will read like a string. Okay. So second value also it accepting like a string. So in the last class we learned what happens when I do plus on two strings. What it does, it has performed concatenation operation, means combining the two strings. So then it is accepting plus 3 it is accepting. So we get result as 103. Is this 103 printed or not? This is the way it will work. Then what can I do? What is the data the user has given that I don't want to accept like a string type. I want to accept this one like a integer type. So manually I need to convert this given string type of data into the integer type. So that we learn typecasting functions. Using typecasting function, what is the input end user has given that need to be converted to the integer type. Okay. So equal to, the statement will be modified like this. Integer function I am writing. This integer function is to convert the accepted input to integer type. So how can I accept the input? Just I will write the input function and I am asking user to give an integer. Enter an integer. Next. Similarly, you write for y and you will print x plus y. You will get 13 instead of 103. So let us check whether it is working or not. So I am adding additional function, that is int function, again closing. Similarly, I am writing another int typecasting function and I am closing. So when I run this one, again the previous method, it is accepting me two it is asking me to give integer value. I have given 10. Next, I have given 3. When I hit enter, it has printed 13, but previously it has printed 1 or 3 because in the previous case, it accepted like a string format. But this case, what is the string we have given will be converted to integer. That integer number can be held inside X variable. Similarly, we will go for subtraction, multiplication, division, and we'll see all these are working or not. So second one, subtraction minus, next multiplication, next division, next floor division, next modulus. Next, I am going to add one more thing, that is power operator. 2 stars. And here I will change messages also. This will do subtraction. This will do multiplication. This will do division. This will do floor division. This will do modulus. This will do. Now I am renting. So I am giving 10 and I am giving 3 and I can see results. So did you observe the difference between division and floor division? Division has given 3.333 like this. And the last digit, it has given 5. So instead of continuing these 3 values, just it has changed from 3 to 5. This has given by the Python standard itself. It is not defined by ourselves. So 10 by 3, 10 modulus 3, we got 1. 10 power 3, we got 30,000. This is the way we have to take the data from the end user dynamically and using input function, converting to your required type based on the type casting, and we perform these all arithmetic operators. Now, we will go for another type of operators. So the second type is relational operator. Relational operator. So what does this relational operator do? It will perform relational operations on two values. This is X value and Y value, and we will get the result in Boolean type. What is mean by Boolean type? We will get the result in Boolean, means which is true or false. We will get the result any one from these two. So let us know what are the relational operators were present. So first one, less than. Second one, less than or equal to. Third one, greater than. Fourth one, greater than or equal to. Fifth one, double equal to. And sixth one, not equals to. These are the 6 different operators were present in Python. Let us see what are the syntaxes and what are the results we get. So syntax of this one. So these all are binary operators. Binary means at least we need 2 operands. So X is one operand, Y is one operand, and I am going to write less than. X less than or equals to Y. X greater than Y. X greater than or equals to Y. X double equals to Y, and X not equals to Y. This is the syntaxes I have written. Next, let us see what are the results we will get for this all when I go for x value as 10 and y value as 20. So let us observe 10 value, x is holding 10, y is holding 20. I am saying x value is less than to y. So 10 is less than to 20. Is it true or false? This is true. So we will get result as true. Next, x either less than or equal to y. So is it less than or equal to? If any one is true, result is true. So x is less than to y. So we will get it has true. Next, I am saying x value greater than to y. Means 10 value greater than to y? No. So we will get result as false. Next, I am saying x value greater than either equal to y. So it is not greater than, it is not equal. Both are false. So result also giving it as false. Next one, x double equal to 5, which means it is going to test whether left side value is equals to right side value or not. Now x is not equals to y, but I am saying x equal to y. So it is also false. So I will get result as false. Next one, 10, which is not equals to 20. Is it true or not? Yes, it is true. I will get result as true. So these are the results I will get when I perform these relational operators on 10, 20. Okay. So we will execute these programs and we'll test whether it is executing or not. Now, so instead of this one, as usual, I am taking x value, y value again dynamically from end user. Next, I am going to test whether they are printing Boolean results or not. X less than y. Next, print x either less than or equal to y. Next, print x greater than y and print x either greater than or equal to y. Print x double equals to y. Next, print x is not equals to y. Now, I will test whether they are working or not. Yes, when I run this one, similarly, the previous program it is asking me to give first integer. I am giving 10. For the second integer, I am giving 20 and I am testing the result. So it is returning to 2 and it is false, this is false, which is false and it is true. So this is the way we will get the results of relational operators. Next one. One more thing I forgot to tell you. So these relational operators, we also call this one as comparison operators. So if you if you see the different textbooks, you can see different terminology, but the operators belonging to these two are the same. Next one. Bitwise operators. So what are the bitwise operators are present? So the name itself, it is saying that these operators can be performed by bit by bit. So let us understand what is bit by bit, how these everything will be performed. So under bitwise operator, we have first one bitwise and this one we are calling it as a bitwise and next one, this pipe notation, this is bitwise or next one, this caps notation, this is bitwise XOR Next one, negation operator. This is bitwise negation. And this is left shift. And we have two greater than notation. We are calling it as a right shift operator. Which right shift? Bitwise right shift. Just you write bitwise prefix of this everything. Bitwise right shift. Let us know how these operations can be work. So here, this every bitwise operator can work on only integer values. If you work with the float or any other type, definitely it will return error. Now, so here, coming to this, these three and these two are the binary operator. Binary means at least we need two values. But coming to this negation, this is unary operator. Unary means I need only one value to perform this operation. So let us see how to write the syntaxes of this all and what are the results we will get for this. So here, and this is x and y I am writing. Next, this pipe notation, x or y. Next one, x or y. Next, negation. So we need only one value, which is negation x. Next, left shift. So x, left shift, and we have to write number of shifts. Here I am not writing y directly. So why I am not writing y directly, will understand at the type of evaluating this thing. Next one, x, I need to be perform right shift operation. And how many shifts you want to be performed, that we have to write that number at the right hand side. So let us write the results for this operator. So like addition and relational operation means for like arithmetic and relational operator, you can't write these results directly. How this can be performed, we will see in detail. Before that, I am going to initialize some values to this x and y. And what are the results we will get for the given values, we will see. For example, x equal to 45 and y equal to 35. These two values I have given. And when I perform x and y operation, let us see what is the result we will get. So here, first you should know how these bitwise operators can perform. So x equal to one integer number you give, y equal to one integer number you give. What are the numbers you are giving? Generally, you will give these values in the decimal representation. This is also decimal. What is the decimal value you have given will be converted to the binary number. Binary number. So I will tell you what are the results we will get for this one. To get that result, manually you have to do this one, but this everything can be done by the system itself when you write AND operator. Next one. So here we will get the binary value. Binary value means we will get zero sign ones. Next one, again I will get binary value. Okay. After generating these two binary values, we need to perform the respective bitwise operator. So we will get the result in binary only. Binary result we will get. What is the binary result we get? That we need to be convert again to decimal representation. What is the decimal value you will get? That is the result of that x and y. This is the result. So let us know how to do this one. So what are the values I have given for x and y? X equal to 45 and y equal to 35. What is my job now? The given decimal representation need to be converted to the binary form. So to convert the given decimal number to binary, very simple thing. What is the decimal value I have given that need to be divided with the 2? So when I divide this one with the 2, I will get the remainder. That remainders you need to be note down. So 2 2 ja 4 and there is no any remainder, and 2 2 ja 4, I will get remainder as 1. Next one 2 2 11 ja 22 and I won't get any remainder which is 0. Next 2 5 ja 10, I will get remainder which is 1. Next 2 2 ja 4, I will get remainder 1. 2 1 ja 2 and I will get remainder as 0. Next, once this division is completed, what the results means the remainders we need to collect in the reverse order. So what is the value we got? This 45 value 1 0 1 0 1. This is the result. Similarly, we need to find 35's binary value. So what can I do? 35 I am taking. Again, I am going to divide this number with the 2. 2 1 ja 2. I got remainder as 1. 2 8 ja 16. 2 7 ja 14. And I will get remainder 1. 2 2 8 ja 16. And I have one remainder. That remainder I am not writing it here. 2 4 ja 8. Remainder is 0. 2 2 ja 4. Remainder is 0. 2 1 ja 2, remainder is 0. Again, I need to collect these all values in the reverse order. So before writing this one, let us check whether these values count is same or 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. These two are having same number of digits. So you can write these digits 1, 0, 0, again 0, 1, 1. Next, what can I do? I will perform bitwise operator on these two numbers. What is the first bitwise operator we have? AND operator. So how can I represent this one? Using AND I am writing. So here, first, we should know what are the AND rules. So we learned these concepts while learning the HTLD subject. But I will write these results one more time. So x is a value and y is a value, and when you perform x and y, these x and y are Boolean values, means either true or false you will write. So while typecasting, I said what does 1 represent, what does 0 represent. 1 is nothing but true, 0 is nothing but false. So I will go for combinations of these all and we'll check what are the results we will get. So here 0, 0, which means two results are false. 0 and 0, its result is also 0. 0, 1 means one result is false, one result is true. But when you join these two using AND, again we get 0 as a result. 1, 0, its a result is also 0. But when these both results as true, I will get the result as 1. So here, let us see what is the result I will get when I perform bitwise operator on these digits. So we'll see this result. So 1 and 1, its result is 1. 0 and 1, 0. This one is 0, this one is 0, this one is 0, this one is 1. Now, what happens? I got the result in the binary representation. What is my next job? I need to convert this value to the decimal representation. So how can I convert? Very simple thing. We need to go for 2 to the power of n table. So let us see how can we write, where n number will begins from 0. So 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5. Like that we need to write, and we will find its value. 2 to the power of 0 is nothing but 1, 2, 2 square is 4, 2 cube is 8, 2 to the power of 4 equal to 16, 2 to the power of 5 equal to 32. So you need not to remember this one directly. You can write this one also. Very simple thing. It's a right side value need to be multiplied with the 2. You will get this left side value. Again 2 2 ja 4, 4 2 ja 8, 8 2 ja 16, 16 2 ja 32. If you continue like this, 64, 128, 256, 512, like that value will be added. Next, how can I generate this result? Wherever you have ones in the result, binary result, that values you need to be take, and you need to do sum of the two operator. So I got this position is 1, so I will record this number, and another one I got at this place, so I will take 32. So just you do sum of these two number, 32 plus 1, I will get the result which is 33. So 33 is the result of 45 and 35. Okay, so let us check whether it is giving this result or not. So I am not writing program. At last we will write this program, but directly I am testing at this shell. So 45 and 35. So when I hit enter, I got 33. Is it clear? So I got 33. So this is the way bitwise operator perform. Now I said this one mathematically. So similarly, we will write results for this remaining all. So this value is 33. Next we will do on OR operator. So to do OR operator, just again I am recopying this thing. Okay. We'll write this one more time. X equal to 1 0 1 1 0 1, y equal to 1 0 0 1 1. Now which bitwise operator we need to perform? OR bitwise operator we need to perform. So OR we are representing using the pipeline notation. Now, before performing this one, we will see what are the results of OR operator. So, this is X, this is Y, and X or Y. So, if these both results are false, X or Y also false. If any one result is true, result is true. 1 1, which is also 1. Now, we will write these results bottom of this one. So 1 or 1, 1, 1, 1, 1, which is 0, which is 1. Again, I need to convert this number to the decimal representation. In the last example, I said how to write this one. Again, I won't write 2 to the power of 0, 2 to the power of 1. Directly, I am writing the values. 1, 2, 4, 8, 16, 32. From this, which values we need to consider? This 32, 8, 4, 2, 1. I won't take 16 because I got the result as 0. Now we find the sum of these two. 32 plus 8, 40, 40 plus 4, 44, 44 plus 2, 46 plus 1, 47. So what is the result of 45 or 35? We get result as 47. Now we will check whether it is printing 47 or not. So 45 or define, I got result as 47. This is clear. Next one. Similarly, we will perform XOR operator. So x equal to y equal to 1 0 1 1 0 1 1 triple 0 double 1. Now we'll apply XOR operator. So to perform XOR operator, again we should know what are the results of XOR operators. I am taking here x and y, x XOR y. So this is 0 0 0 1 1 0 1 1. So when we go for XOR operator, if these two results are same, we get result as false. If these two are two different Boolean values, we will get result as 1. So let us check whether it is working or not. So 1 XOR 1, its result is 0. This is 1, this is 1, this is 1, this is 0, this is 0. Again, we will find this one. So this is 1, this is 2, 4, 8, and 16, 32, where I need to take only this 8, 4, 2. Remaining, I won't take because its binary value is 0. 8 plus 2, 10, 10 plus 4, 14. So what is the result we will get when I perform 45 XOR 35? We will get result as 14. So 45 XOR 35 and we will get result as 14. So this is also clear. Now we will go for another bitwise operator. This is negation operation. So to do this negation operation, we should aware of 2's complement and 3's complement. But I will tell you easiest method to remember how to perform, how to get the negation value. So if the given value is x, and when you perform negation x, we will get the result as minus of x plus 1. This is the result we get. So here I have given x value as 45. When I do negation x, what happens? Minus of 45 plus 1. So we will get the result as minus 46. If I give x value as minus 35, so already we know what is y value. Y equal to minus 35 if I have given. Negation y equal to minus of minus 35 plus 1. So minus of minus 35 plus 1, minus 34, and result is 34 when I do negation y. So we will check whether they are working or not. So here directly I am writing negation. Negation is available on bottom of escape character. So negation 45. I got minus 46 and negation minus 35. I will get 46. Okay, and I said one thing. These binary bitwise operator never work on float numbers. I will show you that one also. 10.5 bitwise and 3.5. When I do that one, I got result as unsupported operand for and float. So this message, it will return when you perform this bitwise operator on other than integer numbers. So we are clear how this negation is working. Next, last two operators related to bitwise operator, that is left shift and right shift. Now you understand this one carefully how it is working. So x equal to 45 I have given, and here also I am taking same x which is 45. Already we know what is the 45 binary value and we know what is the 45's binary value. What did we get? 101101. 101101. Here also 101101. Now how to perform this left shift operator? So first I am writing variable, x variable. Next I want to shift these all bits 2 times left side. Okay, let us see what is the result we get. For example, you consider these all values are available on the table like this. Okay, next you push 1 time this side. What happens? We will get 1 free space at this side. Like this, how many times you need to push? 2 times you need to push. Then what happens? I will get the 2 free spaces. So how this will be look like after performing 2 push operations? So 1, 0, 11, 0, 1, and I will get 2 empty spaces at this place. Next, these 2 places need to be filled with the 0. That's it. Okay. Now we will find the decimal representation of this one. So this is 1, 2, 4, 8, 16, 32, 64, and 128. And whose sum I need to perform? Wherever 1 is available, that's the sum I need to take. 1 is 4, and next one is 16, 32, and 128. So what is the result? 128, 32, 16, and 4. We get 10, 20, 2 carry 0, 2, 4, 5, 6, 7, 8, 1. So what is the result of this one? 180 is the result. Let us check whether it is returning 180 when I do x left shift 3. So one more thing you have to remember, when I do x left shift 3 means we will do 3 shift operation. Again extra 1 more space you will get where you will fill the 0 value. But I am testing only with the 2. So I am clearing this one. So 45 and 45 I am doing 2 left shift operation with 2. I got result as 180. So did I get 180? I have proved whether it is returning 180 mathematically, and I have shown using the program also. So similarly, what I do, I am going to perform right shift on this number. So how can I write right shift? X right shift 2. Now I am doing 2. So here I have tested with 2. Now I am going for 3. So again, same thing, what happens? These all values are available on table, and this one is the corner 0, 1, 1, 0, 1. Like that it is available. Now which side I need to push? So previously I have pushed left side. So the because I use the left shifter, now it is right side. So I need to push right side. How many times I need to push? 3 times. First time, second time, third time, like that I will push. What happens? So this is available at the corner. So this element is deleted, or this digit is deleted, and this is also fall down. This fall down is nothing but simply deleted. And third time also I am pushing, this one is also deleted. Means these 3 values are deleted. So when these all digits will come this right side, and we will get 3 empty places at the left hand side. So 1, 0, 1, and these 3 places will be the empty places. where these empty places will be filled with the zeros. Now we will find this value. You can say directly this value is 5, but I am going to write the general approach 8, 16, 32. Again, I need to take the values where my binary value contain 1. So 4 plus 1, its result is 5. Now I will check whether it is returning 5 or not. So 20. So 45 and the right shift. How many times? 3 times I am doing. I got result as 5. So this is the way we need to perform bitwise operators. Okay. So here I am going to test this everything using one program. As usual, I am taking x value, y value dynamically, and I am going to print x bitwise and y. Next, print x bitwise or y. Print x XOR y. Next, print x. This is negation x. Next, print x left shift 2 and print x right shift 2. So I did 3. So I am testing with 3. When I run this one, 45 and 3, I got these all results. So these things we have checked just now. Okay, this is not 3, this is 35. I am executing this one more time. 45, 35. These values we got when I am performing mathematically. Is this clear? Right. We'll join in the next class.